Okay, let's get started. Good morning, everyone. My name is Tuti Trivedi, and I'm a grad student pursuing my master's in Management Information Systems. I've been working with HPRC for the last 5 to 6 months in the capacity of a student technician resolving day-to-day tickets and maintaining the web application. So we'll start off with a session. I'll provide you a brief background about navigating through the HPRC portal. I've shared the link of the HPRC portal in the chat window. If you're not able to access the portal, you need to check your VPN connection. If you're not able to access the portal after connecting to the VPN, please let us know. In case of any questions throughout the sessions, you can post your questions in the chat window and raise your hand and we'll get back to you. Starting off with the HPRC portal, it's an open source web platform which allows the users to access the HPC clusters and services through a web-based application. We get an access to a UI through which we can interact with the HPRC cluster. The key services for the HPRC application are job submissions and monitoring, file transfer, file management, file editing, accessing the shell script, and accessing the interactive applications. Now let's get started with the portal. This is the landing page of the HPRC portal. As you can see, there are landing accesses to Ada and Terra terminals, and there is a user guide over here, which provides an option. There's an on-demand user guide, which provides an option to resolve any doubts in case of accessing the terminals. Let us navigate through the portal. We have the file explorer option. Now, when you connect to the HPRC cluster, there are two main directories, the home directory and the scratch directory. The file explorer provides an insight of all the files in the directory structure that are present on the clusters. You can view the files, edit it, and you can change the directory structure, as well as you can create other directories on top of the existing one in either your home or the scratch directory using this functionality. The main purpose of this functionality is to either upload or download files from the server to and from your local system. Another option is of the job composer. You'll be able to see all the active jobs which you are running. When you submit the jobs for running on the cluster, you'll be able to see all the active jobs. Currently, none of the jobs are running from my system. So if I want to submit a job, I would use a job composer to do so. Here I have an option to create a new job, a default one, or use a template which is available. As you access the job composer option, you can see the jobs which you have previously submitted, be it parallel jobs or serial jobs. Serial jobs are the one in which you access one node, one core per node, and the parallel ones are provide you an option of accessing the multi-threading nodes. You can leverage the template and you can easily submit the jobs. There's an easy access to the Ada and Terra cluster shells. And coming to the interactive applications, the on-demand portal provides an application of submitting the jobs user interfaces using MATLAB, VNC, Abacus, and other options. Apart from hosting servers like Jupyter Notebook and Jupyter Lab. Let's get started with Jupyter Notebook. In order to launch the Jupyter server on either Ada or Terra cluster, you need to select a module. Is everyone able to navigate through the portal? Are you able to land to the Jupyter Notebook launching session? You can stop me at any point of time if you're not able to navigate. You'll not be able to access the HPRC terminal without the net ID and password and the credentials. So maybe you can just monitor the session as of now, and parallelly post the session, we'll be sharing the recordings as well as the presentation of the session, and you can execute the hands-on exercises then. The recording will be available. It will be posted on the HPRC Primer YouTube channel. We'll share the link with you very soon. The channel will be accessible from the HPRC homepage. This is the link to the HPRC YouTube Primer channel. We have a home channel as well as a Primer channel on which the exclusively Primer content would be launched. Yes, we would follow the exact same content for the afternoon session as well. Okay, so starting off with launching the Jupyter Notebook. The primer would take a couple of days to be uploaded on the channel. Okay, so I believe most of you are able to access this particular landing page. So let's get started with the Jupyter Notebook and perform some hands-on exercises. You can select any module, be it Anaconda or Python. We can create a virtual environment for running our Jupyter server on top of those ones. But if we create a virtual environment on the cluster, I will show you how to do so later in the session. We need to be very sure that the Python module that we are using, currently we are using the 3.6.6 FROST version, and there are the Anaconda versions which are mentioned over here. You need to be very sure that you use this exact same version for creating a virtual environment as well. I'll go ahead and select the Python module. This is an optional optional environment to be activated session. Now here you can create a virtual environment and activate the virtual session on your Jupyter notebooks using those sessions. We'll get back to this session later. There's an option to add additional modules if required. Currently, we'll not go ahead with this. Number of hours for which you want to run the Jupyter server. You can keep it from 1 to 2. Number of cores used. Since we are not performing a lot of heavy scale simulations, the number of cores used can be 1. Total memory can be minimal, which is 2 as of now. If you run any application with memory less than 54 GB, the job will run on 64G memory node. In the other case, it will run on 128G memory node. The node type can be either the login nodes or the GPU nodes. Currently, we do not need a GPU simulation, so we'll go ahead with any and choose the login nodes. You can give your account number over here. It's an optional element. You can provide your email ID, and as soon as the session starts. So in some cases, if the server is busy, the request will be placed in a queue, and you can access the queue, and as soon as your turn comes up, you'll get an email pop up and you can start using the server. When I click launch, my server is about to start. This is my particular job ID for the session that I've just started, and this is the session. If I click on this particular session ID, I can see an option of output log. Now, in some cases, maybe the module that I have selected is incorrect. So under those scenarios, my Jupyter server won't launch, and I'll face a runtime error. While accessing the logs, I'll be able to see which is the error. So for launching the Jupyter module using Python, all the dependent, as you can see, all these dependent modules are loaded, and the Python version that I just chose is loaded. So now my application has started. It is running on port 64399. You can parallelly see if your application has started and it's running on the port. The port number can differ in your case. Okay, now I have an option to connect to the Jupyter Notebook. Is anyone facing challenges to connect to the Jupyter Notebook? Did you face any runtime error, or were you smoothly able to connect? If you face any error across the process, just let me know. Okay, so this is the Jupyter environment. This is the file structure in the Jupyter environment. You can create new files using new, notebook, and Python 3 option. Now, depending upon your Python module, it might be Python 2, Python 3, or maybe Anaconda. If you have chosen Anaconda environment before, it can be Anaconda. So the kernel has started, and I'm able to see my notebook. Okay, so let's start off with a hands-on exercise. We'll create a new directory first. We'll launch a new notebook inside that, save the file, and print a basic welcome message using the Jupyter Notebook. So over here, I can click on new folder. This is my new folder. I can rename the folder accordingly. I'll name it as Jupyter session. Okay, here I'll create a new notebook. Let me rename the notebook to Jupyter Basic. Now, in order to rename the notebook, there are a few naming conventions that we must use. The module name must be in lowercase. If we have more than one characters, like I used right now, we need to use an underscore, like mentioned over here. And in case if you're naming the classes, it must be in the camel case structure. Okay, so I'll print my first message. In order to run, now this is a particular cell in which the simulation is taking place. In order to run this, I can either click on the run option or I can use a shortcut, Control Enter. Jupyter is used for an interactive, easy, one-on-one simulation. Its main purpose is for code debugging, performing mathematical simulations, statistical annotations. So when you want to execute a small piece of code and see if it's working accordingly in your major code, you can use Jupyter Notebooks. Okay, let's start. Let's try. So we have completed our first exercise. We have successfully created a folder, launched a file inside it, and printed a message. Let's try adding two numbers. We'll perform basic Python simulations over here. If you're not familiar with Python, we will perform basic simulations in the notebook so that you can understand how notebook is useful for performing mathematical functions, printing messages. You can perform the simulations parallelly on your system. Now to add two numbers, we need not save it in a variable first and add two numbers. It is quite easy and accessible. If I want to just print summation of two numbers, say 1 plus 5, I can just print inside and I'll get the result. Accordingly, if I need to create a variable and name it as a string, I'll be able to print my variable as well. Now we all know that the type of this variable is string, but let's check. Okay, this would return the type of the variable, which is string over here. Now let's get into some looping logic. If I want to print first 5 numerical numbers, I would use for loop for the same. Now I'm iterating through, I'm using a variable and I'm iterating through the first 5 or first 10 numbers. So if I choose first 5 numbers, I selected this and I would print the number. Within, you have seen that within a single cell, you can perform all the simulations and with very few lines of code. So we have learned to create a new notebook. We've learned to rename the notebook, running the cells, and perform some basic Python applications. Now the server that we use for running the Jupyter Notebook is called a kernel. We have a few options of restarting the kernel, changing the kernel version, and removing the kernel. This is the kernel. I can restart the kernel. There are options of restarting and clearing outputs. If I want to get rid of the piece of code that I have done the simulations before, I can restart and clear the output. I can restart and run all, and I can also reconnect. If I'm facing a few challenges, I can reconnect or I can shut down the kernel. Let me restart the kernel. That would, and as you see, the file gets auto-saved. You can use to add new cell, you can use the plus icon. To delete those cells, you can click on the scissor icon. So these were some basic Python simulations. So kernel is a server. If you can see over here, the kernel we are using currently is Python 3. So that is the Python environment on which the entire system is running. If I use, I can use Anaconda, I can use Spark, uh, and other features for running my simulation. On Jupyter, I can use any sort of code. I can use Python, I can use Spark simulation, I can use Taurus, and I can also perform some R simulations. So for that, I would load an R module, and I can add as many kernels as I want to. I can run in a parallel window. If I have an R module loaded in a parallel window, I can open up the R module and I would use that particular kernel. So if you see, I'm using Python right now, so that's the reason this is Python 3. If I have Anaconda or R in a parallel window, I would run those simulations and use that particular environment and module. Okay. In Jupyter, so we use the Jupyter server on the HPRC clusters. Now we can do few simulations like copying files from one position to another. We can use the IPython shell commands, which are quite hands-on, and that can be used in the Jupyter cell itself. Let's see how to do that. Okay, for that I'll create a new Jupyter notebook. Can rename it to Jupyter shell. Okay, now if I want to print my current directory, for printing current directory, these are Linux commands, and for printing current directory on Linux, we use a pwd command, right? Similarly, on using Jupyter, using the IPython option, we use the exclamation and pwd option. This is my current directory. If you remember, by default, I would be routed to the Scratch directory. As soon as I log in on the Jupyter server, I would be directed to the Scratch directory, and this is the folder that we created, Jupyter session. I can list my files that are present in the current directory. These are the two files. One is the basic one that we created before, and this is the shell option. Similarly, we can use other options for navigating through. So the main purpose of the Jupyter Notebook application is we need not log into the server to copy files from one location to another, or to make new directories or manage the folder structure. We can do it at a cell level using the notebooks. So I can try creating a new directory and copying this particular file there. For using basic applications like printing the password or listing down the files, I would use exclamation and the command. But for the major operations, we use magic commands for changing the directory, making new directory, copying file. And for that, we use a percentage and the Linux command. So let's see how it's done. I use this option to make a new directory under Python session. Let me call it backup. Okay, so new directory is created. If I want to copy my file, Python basic, to the backup folder, okay. So I'm able to copy the file. Let's route to the backup folder to check if the file is copied. Now I have moved to the backup folder inside the Jupyter session folder. And let's list the files inside this. So the file is successfully copied. I can delete the files and perform any other operation that I do in Linux using the sets. Okay, so the Jupyter Notebook function has a very important parameter called markdown parameters. We use HTML, the hypertext markup language. Similar to that, we have a markdown language, which is embedded inside the Jupyter functionality. Yeah, so like it is mentioned, the kernel is the engine that executes the code. It's the basic engine that is used to execute any sort of code, be it Python, be it R, accordingly. Now, if I want to see how many simulations I'm running, I can click on the running icon, and I see there are 3 files. So this is the file that I created earlier, and these are the 2 files that we are using for our current simulations. Okay, we'll create one more file. Here we have an option for the markdown. So if I want to choose a header, for choosing header in HTML, we choose the H1 tag. Similarly, you can do a hash. Welcome to HPRC, run it in the markdown mode. This will print it in as a heading 1. But if I want to print a smaller heading, say H4 level, I need to use 4 hash symbols. Make the mode as markdown. This shows the different level of headers that we can use. All of these codes are inline and you can use it as within your cell itself. If I want to make the entire thing in bold, I can either use the B tag that we use for HTML, but I need to be very careful and run it in the markdown mode. Or there's a shortcut of running the same. This is how this text got bold. If I want to print a horizontal line, there's a shortcut. So these type of formatting and editing features are inbuilt inside the Jupyter Notebook. You'll have to clone a module if you want to run it as if you want to use it as a kernel and run it on the Jupyter environment. You will have to clone a module and use the same. For example, while using the kernel, if I want to see the list of all the kernels which are present in my environment, currently I'm connected to the Terra environment. If I want to see the list of kernels that are present over there, I can use the particular command, Jupyter kernel spec list. I can use this one for maintaining my kernels. I've navigated to my Scratch directory. Once when I activate the environment, currently I haven't activated the, I can show you the list of the entire list of kernels that I have. You can also embed a link within the cell. You can use this particular option for doing so. If I want to embed the HPRC link within the cell, so within the box, I name the link, and this is where I provide the link option. This is similar to the href option that we use for normal HTML. This is the HPRC link. Okay, so on clicking this link, I'll get an access to the HPRC homepage. As you can see, I got an access to the HPRC homepage. So you can embed the link within the cell. But this is mainly used for embedding a piece of code that you want in the exact similar way. If I want to copy an entire Python code, I can use it using the markdown option. For example, it's a basic code which is printing a string. So you can use you can use this particular sign to, and whatever text you embed inside this would be this is called a markdown option, and whatever text you embed inside this would be printed. So this code is this is an entire piece of code but basically for running mathematical simulations, if you want to use the sigma sign or the square root sign, you can use this particular markdown option. Whatever you enter between the $2 sign, the mathematical expression that would get read. So we need to know the ASCII value for each mathematical character. If I want to print the square root, I can, this is the ASCII annotation for the same. I'll get a square root option. So accordingly, I can embed my mathematical operations inside this. Okay, so till now we have seen how to create a new notebook, how to navigate through the file structure using the IPython options, and how to format the particular notebook, as well as embed links inside it and using it for mathematical simulations and operations. The main purpose of Jupyter Notebook is to run Python numerical Python Numpy operations, the numerical operations, or running data frames. If you have a huge set of data in the form of a CSV or in the form of an Excel, you can use the data frame feature of Python, which allows you to create a denormalized table in which you can have you can merge data from two CSV. If you have millions of rows in a particular CSV, you might not able to load it in a single go. So in order to perform extraction, transformation, loading, ETL functionality for creating new data models, this is an extremely beneficial feature in which you can use the columns, in which you can create a virtual table. You can use whatever columns you require from the Excel sheets, create a virtual table, add the number of rows you want, and run simulations on the top of that. So for doing so, we use numerical Python, Numpy, or the data frame feature. Numpy also provides an option of providing mathematical simulations inside the cell. So let us go to the Jupyter environment again. I have a notebook which is already created for the NumPy functions. I would just upload the notebook. This is the way you can upload any notebook from your local system or from the servers. Okay, so here I have two arrays. One describes the height and the other one describes the weight. I can import any module on the go within the cell. So I've imported a NumPy module. Then I've created two arrays with the same. Now, in order to get the BMI, I am running the particular mathematical function of weight over height into 2. So I get a list of BMI by comparing the height and the weight. Now, if I want to parallelly check if any operation, if the BMI is less than 25, I can run the parallel operation over here and get those observations. If I want the list greater than 23, I can go ahead and change this. Okay, so now because I made the change in this particular cell, I need to run all the 3 cells, because if you see, the BMI that which is getting used over here is getting calculated in the second cell. So I need to get the data from the first cell, for which I would run the first cell, then the second cell, and then I would be able to run the third cell. So this is the change that we executed. So parallelly, NumPy can be used for any mathematical simulation. Another interesting feature of Jupyter is the Matplot functionality that is used for plotting graphs. I will share all the Jupyter notebooks with you. Okay, so the similar way that I had imported NumPy before, I have imported Matplot, and I have provided the X and Y axis. If you can see, this is the X axis, this is the Y axis, the upper and the lower range have been provided, and the show functionality would provide me the nodes. So these are the points which are plotted: 1 cross 1, 2 cross 4, 3 cross 9, and 4 cross 16. These are the points which are plotted, and this is the shape of the graph. I can also plot different sorts of graph, like the bar chart, bar chart, scatter plot, and the different variety of graph that you can see over here. I just need to provide a rough range of the data that I would like to capture. Okay, so for for creating a virtual environment, we can either use Python or Anaconda on the servers. We'll try a small demo. I'll connect to the Terra server and launch a virtual environment using Python. This is my Terra application. For running Jupyter notebooks and using Anaconda application for the same, you should have the file space more than 10,000, because Anaconda, as soon as you load the Anaconda module, it loads more than 10,000 files. So I can quickly see my file limit. As you can see, my file usage is around 26,000, and I have a file limit. So you can use the particular cluster in which you have enough file capacity. Now I'll move into my Scratch directory. I'm currently inside my Scratch directory, Scratch user and net ID. I'll make a folder over here. Named Jupyter session. Now I'll start a virtual environment over here. The steps to launch a virtual environment are present over here. You need to load a Python module, the module which is similar to the one which is running on the portal. So you can clear all the modules which are present on the cluster before using module purge, and then you can use module load and load any module of Python that you would like to run. But since we have used, while using the Jupyter Notebook, we have used this particular version of Python. I would be using the 3.6.6 version of Python. And load this particular module. Okay, now I'll go inside the Jupyter session directory. Now I need to create a virtual environment. To follow these steps, all these steps are mentioned in the wiki portal. The link for the portal is provided over here. Starting from connecting to the clusters, using the portal, using it for various applications, access the link to access the Ada and the Terra portal directly, as well as if you're facing any issues with the two-factor authentication or connection with the VPN, all the details are provided in detail on the wiki link over here. The details regarding the file explorer system that we saw before, the file editor, the link to the clusters, various jobs. We did not go into detail because it's a separate session of how to submit a job application, a job composer application. But in detail, to submit a serial job or a parallel job has been described over here, apart from various interactive applications. You can navigate directly to the Jupyter session. You can follow these particular steps to launch a virtual environment. Now I loaded the module in order to load a virtual environment named My Notebook Python. I would use the following functionality. I would use the virtual env function and create a folder over here, naming it Jupyter Virtual. So this is loading all the dependent modules, the modules that we saw before while starting off the Jupyter session. This is loading all those modules. All these dependent modules are getting loaded along with the Python 3.6.6 module. Now, once the virtual environment is created, we need to activate the environment. This is the command to activate the environment. You need to go inside the virtual environment that you created and bin activate. Source. The virtual environment is activated. Now I can install Notebook over here. Now I need to use the exact same path, which is present over here to launch the Jupyter Notebook like we did before. I can use this particular module, and in the optional environment session, I can give the name of the exact path where I have my virtual environment created. So it was under a folder Jupyter. For me, it's under the folder Jupyter session. Inside that, virtual environment. Named Jupyter Word. Pin activate. Now I can use this, but when I use this particular path, I would be using my Python environment, my virtual environment, to run the Jupyter Notebook. As you can see, this is queued because the first session is running. In a similar way, I can start my application and run the notebook and run various simulations that we were running before. Now, finally, before you can launch the Jupyter, as we use the Python virtual environment, you can similarly use Anaconda and follow the exact same steps to create an Anaconda virtual environment, activate the source, and run your notebook on top of that. Now, finally, before logging off, we need to log out from the Jupyter Notebook. There's an option to log out. You can click log out option. Along with clearing the browser cache properties, you need to log out of the browser cache as well. And as I mentioned, when you create the virtual environment, you load a lot of files. So you can run this particular command to remove the extra files that are created in the cluster. Any questions? You can load the modules. You can load the particular command module load. You can use a particular command module spider. If you want to search for the Python modules, you can use a particular command module spider Python. This way you'll be able to see all the relevant modules of Python. Then you can synchronize with the ones that are available on the portal, and you can load those particular modules using module load command. And in the similar way that we use this particular command, module load Python and this exact version of Python. Similar way, you can use various versions of Anaconda as well. Any other questions? Your notebooks would be saved in the Scratch directory. If you have chosen default option to connect to the Jupyter server, it would be saved inside the Scratch directory. If you have chosen a particular virtual environment, it will be saved in that particular virtual environment. There are modules available for TensorFlow. You can check it on the HPRC portal. You can navigate through the software option. This is the HPRC homepage. On the homepage, you can select software option. You can select for the Ada or Terra modules if you want to load it on Ada. Here in the search bar, you can provide option for Tensor. The TensorFlow option. Now, these are the versions of TensorFlow with the suitable Python modules. You can load any of these and then use it in the kernel. And for more information, we have an HPRC Tensor page. You can navigate through this page. If you would be able to import the modules on the clusters and you would be able to start a virtual environment. But when I go ahead and I use a module, which is not a part, when I use a module on the, let me show it to you. Okay, so if I use an Anaconda module 3.6, like you mentioned, but it's not mentioned over here, I'll go ahead and I'll start my Jupyter session and I will save my notebooks. But when I try to reuse it with that particular version, if I have a virtual environment that is running on 3.6, I will not be able to launch the session first of all, because it will create a runtime error. You can choose any module which is available from all of these, and you can choose your Anaconda or Python modules that are, which is similar to these. If you choose anything separate from this, you will face a runtime error when you try to launch your session. If you're able to launch your session, I believe on Ada, we support the 3.6 version. The ones that are mentioned over here is 3.5, but if you're able to use it as a virtual, if you're able to activate the virtual environment and run run a Jupyter session over here, there won't be an issue. Just make sure that you save your notebooks and try to when you try to upload it, just make sure that there are no incompatibility issues. So we have nearly ended the session. Please fill out the poll. Like I mentioned before, the The software page consists of all the details of navigating through the HPRC portal. Everything is described in detail on the page. If you have any concerns, you can reach out to us. You can drop an email or you can reach out to us. Those errors are maybe because of the incompatibility of the modules when you're trying to load an Anaconda 3.6 and when you're trying to use the available modules which are 3.5 on the portal. That's because of the incompatibility. You can use any of the modules which are listed on the portal. If any of you have any questions regarding, you can follow these steps, you can follow the software wiki link, and if you have any questions, you can reach out to us.